Right, so we looked at how to graph polynomials by hand. This time we're going to look at how to graph them in the calculator. Now, graphing the calculator is very similar to graphing anything in the calculator. We need to turn the calculator on. I'm going to tilt it here and try and correct some of that glare. Right, we turn our calculator on and we go to our y equals screen. Now, I've already typed it in because there's no need for you to watch me type. If you have forgotten or didn't know, when we have an exponent that is not 2, right, we have a squared key for putting x squared in. But if we have a different exponent than that, we have this to the key, this little caret here. So you would do x to the 4th power to get x to the 4th. And the rest, I'm sure you know. Now, for this particular one, this in my math lab, they're going to give you this window, and it's going to be a multiple choice deal. You're going to need to identify the graph that looks most like yours. And if you don't set the window up correctly, you're not going to be able to tell. So go to window, and remember the first number is x min. So put a -5 in x min. The second is x max. Skip the scale. The third is y min. And the fourth is y max, so put those in the right places. We don't need to touch x scale or x res at all. And we got our graph, hopefully. All right, so we would choose the one. I'm not going to bother trying to copy this onto paper. You're not going to need to graph it. You just need to choose the appropriate choice in my math lab. It looks like a parabola almost, but it's a little lopsided. And it's got x-intercepts at a little bit more than -1 there, or a little bit less than -1, and somewhere between +1 and +2. So that's what you want to look for, the right basic shape and the right approximate x-intercepts. If we tried, we would try to factor this. We would not be able to factor this and find the x-intercepts exactly. So we do need to use the technology here. All right, so let's look at this next one. This one's given to us in factored form. So it should be fairly simple to put into the calculator. I get the glare there. Go back to y equals. Clear out the old one. We get negative. Remember, use this guy for negative, not the subtraction. So -x, and then x plus 2, close the parentheses, and x minus 4, close parentheses, to the 3rd power. Now, I don't want the window for this graph for our new one. I want our regular window. So I'm going to go back to that regular one, which is zoom, and then either arrow down to standard and hit enter, or 6. Zoom 6 always gets you back to that nice home screen. And that's fantastic. I can't really tell what's going on here, but you should be able to interpret this, what you know about this graph from this information here. You know that it's got an x-intercept at -2 and +4, which we can see on the screen. But we also have an x-intercept at 0, which we can't really see because it's just drawing over the y-intercept there, or the y-axis. But we can use the calculator to help. We know the right basic shape here. We can see the behavior at 4 and the behavior at 2, but we need to add in the behavior at 0. So at 4, we've got this little wiggle sort of thing going here. We know that end's going down to negative infinity. It's crossing at 2, but it's also going to cross at 0. And those are straight through crossings, right? Because of the multiplicity of 1. So our graph's going up here, down through there, turning around and going back up that way. Okay, so straight through, through with a wiggle. That's consistent with what we see here, but we need to be smarter than the calculator. We need to know by looking at that we have that x-intercept at 0. All right, so whenever you're graphing, use your calculator to help you and to check your work. Even in the last part where we were graphing polynomials by hand, after you're done graphing it by hand, pop it in the calculator and see if you get the same thing. If you do, you did it right. If not, try again.